attend to this now. The South African National Roads Agency is warning that increasing freight volumes on the N2 destroying the highway. The national route, which stretches from Ermelo to Cape Town and is key for coal exports to Richards Bay, has seen an estimated 140% rise in volumes. The collapsed rail system has been blamed in part for this situation. Sanral engineer head Louw Kannemeyer joins us now for more on that. Good to have you, and thank you very much for your time. When roads, national roads, urban roads are being built, what are the factors that you consider in terms of the projection of how long this road is going to last and how the road is going to be used?
Hi, evening, Thabo. Yeah, thanks for the opportunity. Yeah, I think it's important to understand that obviously when we design roads, we very much look way into the future, and we do various projections based on traffic and the anticipated traffic growth on that specific corridor. And what is of critical importance is the number of heavy vehicle axles that we will expect. So it's important to understand that we don't design a road to last for 25 years. We design it for the heavy vehicle axles we expect in that 25-year period. So if anything changes that impacts those projections, so say for example like what we see now, a sudden move from rail to road that results in way above growth than what we ever anticipated, that original number of axles we expected in the 25-year period will now be carried in a much shorter period. So you will then see the 25 calendar years maybe only becoming 5 calendar years at the much higher heavy vehicle number of axles that are then making use of that road. So that is the most crucial factor that plays a big role when we design a pavement in terms of its life expectancy, as the number of heavy vehicle axles we expect on that corridor.
Now, based on how we build our road, when those factors change, as they have now, either because of inefficiencies within our rail system or within our ports, are you able to intervene after the fact, after the road has been built, to say, oh, well, now it seems we are going to have more trucks coming on, and therefore let us reinforce?
Yeah, so what will happen is we're continuously monitoring our roads, both from a condition and a deterioration trend using specialized survey vehicles. We're also continuously monitoring the vehicles that are making use through automated traffic counters that are embedded into our roads. That information is continuously fed into our asset management system, which we use to do 30-year projections, assuming certain climatic conditions, certain economic scenarios. And that continuously informs us in terms of the maintenance strategies that we need to follow for each and every route over the next 30 years, and also how that needs to be amended to deal with these changes in either climate or usage that we're observing from our monitoring. And that will then dictate, as you correctly indicate, that we might sooner have to do an action that needs to strengthen the road for the increased traffic that we're, for example, observing on that corridor. Or if it's an increase in light vehicles, we might need to add additional lanes to ensure appropriate level of service along that corridor.
So why would, for example, a road like the N3, which sees, I am guessing, a number of trucks, maybe substantially more trucks than the N2 from Ermelo to Richards Bay, would still be fairly intact for longer than a road like the N2?
Yeah, so I think that's the important part to understand, is that at the time when the N3, when we do the design, the base traffic load that we use in our assumptions we're already sitting, say, at 2,000, 3,000, 4,000 vehicles per day. So you are designing from a very high traffic base. So when you're projecting forward, any increase is then really marginal compared to your design base. But when you depart on a road that typically served farm to market traffic, and it suddenly jumps from an expected 200 heavies per day to 2,500 heavy vehicles per day, you can see the substantial shift. Whereas on the N3, we're already running at 7,000 trucks per day. So an increase of 1,000 trucks isn't that huge proportionally compared to going from 200 to say 2,500 per day on the N2 from Ermelo to Richards Bay.
Yeah. So in a road like that, we're talking about on the N2, I mean, at what point are we going to be saying that road is no longer drivable, so to speak?
Yeah, so from a Sanral side, I mean, the people that are using that road would have seen, I mean, we already had to intervene with various measures in the short term to just keep the road safe and operational. We actually now already have issued 3 large construction tenders for the complete reconstruction of that road. Those tenders have already closed, and we're now busy with the evaluation and the adjudication of those tenders. So we've already triggered major improvement projects along that corridor that not only will see us reconstructing the existing road, but we actually will be adding a new carriageway. So there will then be 2 carriageway, allowing us to separate the northbound and the southbound traffic, like what you see on the N3, for example.
Yeah. And how do you determine then what resources, what investment you're going to make? Because, I mean, if you're saying you're going to make another carriageway and then, I suppose, things improve at Transnet, would that be a worthwhile investment?
Yeah, so I think obviously one needs to understand there's obviously current rail inefficiencies that is causing the short-term movement to road, especially with the high commodity prices. So it's very cyclic, but it's really the high commodity prices at the moment for example, coal, is making it cost-effective to haul via road, especially if there's insufficient capacity on rail. When the rail capacity comes back, when they start operating efficiently, it will once again remove a certain capacity. But then when you look at the long-term trends, there is growth where the rail will have a fixed capacity. And what we're doing is really to make sure that there is that alternate available on the road sector should rail have a challenge in future again, that we're not having a corridor that is only serviced by a single mode of transport, and then we end up with commodities that we can't get to the harbour and we can't sell to get much needed foreign revenue for the country.
And how do we ensure that that happens? I mean, I see in your article saying we need to strengthen the road structure by constructing its layers and adding additional layers. Explain that process. How do we make the materials that we use to be stronger? Because others will just simply assume that the companies that are building these roads are using substandard material, and that's why these roads are deteriorating so quickly.
No. I think, it's very important maybe for listeners to understand is that although most roads when you travel look the same, so most surface roads, at the surface they're flat and they will mostly be black in color because of the use of bitumen, which is what we use to waterproof the surface and get water out from not reaching the granular materials. Although they look the same, your urban street in front of your house and the N3 looks the same, what is below the surface is radically different. So your typical urban street will have about 300 millimeters of material below the surfacing, composing of various gravels and things. A typical N3, we've got 1.2 meters of material below the surface of a much higher quality in terms of the layers and how we build those layers in 150 millimeter thick layers to distribute these axle loads. So there's a vast difference below the surface that the general traveling public are not seeing. So in our design methods, we are, as you can see with the N3, it's been taking the loads no problem. It is really now just applying those same material properties or the material types in the layers that will now be applied onto the N2, that will then enable the N2 to then in future also carry the current loads that are there and any future heavy loads that might come onto that corridor.
Louw, appreciate your time. Thanks so much for coming on, engineer head there at Sanral, Louw Kannemeyer.